Tonight, we drift into the quiet mysteries of the universe. You don't need to follow every word. Just let the story carry you like starlight across a calm sky. There is no hurry here, no urgency. The cosmos has been unfolding for billions of years, and it will continue long after this moment passes. So settle in wherever you are. Perhaps you're lying down, feeling the weight of the day release from your shoulders. Perhaps you're watching the ceiling or the darkness behind your eyelids. Wherever you are, you're welcome here. We're going to talk about something strange tonight, something that challenges the very fabric of what we think we know. But we'll approach it slowly, the way you might approach a sleeping animal, with respect, with gentleness, with wonder. This is a story about darkness, about a black hole that doesn't behave the way black holes should. A void in space that grows faster than light itself can travel. It sounds impossible, doesn't it? And yet, somewhere in the deep folds of space-time, it may be happening right now. But before we venture into that impossible darkness, let's begin somewhere familiar. Let's begin with you here in this moment. Feel the surface beneath you. Notice the quiet around you, or perhaps the gentle hum of distant sound. A refrigerator, the wind outside, the barely there whisper of your own breathing. This is where all science begins, really. Not in grand observatories or particle accelerators, but in simple observation. In noticing, in wondering, the universe speaks to us in whispers. It always has. Long before telescopes or mathematics, human beings looked up at the night sky and felt something shift inside them. A kind of vertigo, a gentle unmooring. The stars were so distant, so unchanging, so utterly indifferent to the small dramas of human life. And yet there was comfort in that indifference. The stars would shine whether we watched them or not. They would continue their slow dance across the seasons, marking time in a way that made our own troubles seem beautifully small. Tonight, we're going to listen to one of those whispers, a cosmic whisper that comes from the deepest darkness, from a place where even light cannot escape. But we'll get there slowly. There's no rush. The black hole isn't going anywhere, or rather, it's going everywhere, expanding outward in a way that shouldn't be possible. But we'll explore that strangeness together, one gentle thought at a time. Imagine yourself floating in the silence of deep space. There is no up or down here, no reference point to orient yourself. You are suspended in a darkness so complete, it feels almost tangible, like velvet against your skin. But it's not entirely dark. In the distance, always in the distance, there are points of light, stars, scattered like grains of sand across an infinite black beach. Some are brilliant white, others amber or deep red. They don't twinkle here, not like they do from Earth. Without an atmosphere to blur their light, they shine steady and pure. You drift among them, weightless, timeless. And as you drift, you become aware of something else, a rhythm, so faint at first that you think you might be imagining it. A pulse deep and slow like a heartbeat from somewhere far away. It doesn't come from any particular direction. It seems to emanate from space itself, as if the fabric of the universe has a pulse, a living quality you'd never noticed before. This is the cosmic whisper, the rhythm of something vast and strange. A black hole, yes, but not like the ones you might have heard about. Not the patient, stationary monsters that sit at the centers of galaxies, slowly feeding on whatever matter happens to drift too close. This is something else. This is a black hole that grows, that expands, that races outward through space at speeds that should be impossible. Faster than light itself. How can anything move faster than light? Isn't that supposed to be the universe's ultimate speed limit? The one rule that nothing can break? Einstein told us so, didn't he? The speed of light, roughly 186,000 miles per second, or about 300,000 kilometers per second, is the cosmic constant, the unbreakable barrier. And he was right. Nothing that has mass can reach the speed of light, let alone exceed it. The faster you go, the more energy you need, and as you approach light speed, you would need infinite energy to push any faster. It's a wall built into the structure of reality itself, and yet here we are, contemplating something that seems to violate that sacred rule. A black hole whose event horizon, that invisible boundary beyond which nothing escapes, expands faster than light can travel. It sounds like a paradox. It sounds like a mistake. But the mathematics whisper otherwise, and the universe, as we're learning, is far stranger than we ever imagined. Let's think about light for a moment. Light has always been special. Long before we understood what it was, we worshipped it. The sun was a god in countless cultures, the bringer of life and warmth. Fire was sacred, mysterious, a piece of heaven brought down to earth. Even in our modern age, we speak of enlightenment, of seeing the light, of darkness as a metaphor for ignorance or fear. Light represents knowledge, clarity, truth. For most of human history, we assumed light was instantaneous. You open your eyes and you see. The sun rises and the world is illuminated. There seemed to be no delay, no journey. But careful observers began to notice inconsistencies. In the 17th century, a Danish astronomer named Ole Rømer was studying the moons of Jupiter, trying to create precise tables of when they would eclipse behind the giant planet. He noticed that the eclipses seemed to happen earlier, when Earth was moving toward Jupiter in its orbit, and later when Earth was moving away. The difference was small, just a few minutes, but it was consistent. Rømer realized what this meant. Light wasn't instantaneous. It took time to travel from Jupiter to Earth, and that time changed depending on how far apart the two planets were. He calculated a speed, not perfectly accurate by modern standards, but close enough to reveal the truth. Light moves. It travels. It has a speed. This was revolutionary. It meant that when you look at the stars, you're not seeing them as they are now, but as they were when the light left them. The sun you see is the sun from 8 minutes ago. The nearest star beyond our sun, Proxima Centauri, shows us its face from over 4 years in the past. The Andromeda Galaxy, that beautiful smudge of light visible on dark nights, is a portrait from 2.5 million years ago, when our ancestors were just beginning to walk upright on the African savanna. We live in a universe of ghosts, of echoes of light, that carries messages from the past. And for a long time, light held the crown. Photons, those strange little packets of electromagnetic energy, were the fastest things in existence. They set the pace. They defined what was possible, but they've lost the race. Somewhere in the cosmos, there is a darkness that moves faster than they do, a shadow that outruns the light. And to understand how this can be, we need to change the way we think about motion itself. When we think about something moving fast, we usually imagine it traveling through space. A car drives down a road, an airplane cuts through the sky, a spacecraft hurtles from Earth toward Mars. These things move through space, covering distance over time. And yes, there are limits to how fast they can go. Engineering limits, fuel limits, and ultimately the speed of light itself. But what if the motion isn't through space? What if space itself is moving? This is one of the strangest insights of modern cosmology. Space isn't just an empty stage where matter and energy perform. It's a dynamic substance, something that can stretch and compress, ripple and flow. Einstein showed us this in his general theory of relativity. Massive objects bend space around them like a weight on a rubber sheet. And when massive objects accelerate or collide, they send ripples through space itself, gravitational waves that travel outward at the speed of light. But space can also expand. In fact, it's expanding right now, and it has been since the Big Bang. Galaxies aren't just moving through space away from each other. The space between them is growing, like dots on a balloon as you inflate it. And here's the crucial point. There's no speed limit on the expansion of space itself. Space doesn't move through anything. It is the thing, and it can expand faster than light. This is how the observable universe can be about 93 billion light-years across, even though it's only 13.8 billion years old. If nothing could travel faster than light, you might expect the universe to be only about 27.6 billion light-years across at most, light traveling in both directions from the Big Bang. But space itself expanded faster than that, especially in the first fractions of a second, in a period called cosmic inflation. So the universe already has a precedent for faster-than-light expansion. And if the universe can do it, perhaps a black hole can too. But let's slow down. Let's not rush into the impossible just yet. Let's first appreciate what a black hole is, in its more familiar form. Because even an ordinary black hole is extraordinary enough. Imagine a star. A massive one, many times the mass of our sun. For millions or billions of years it burns, fusing hydrogen into helium in its core, releasing tremendous energy that pushes outward against the inward crush of its own gravity. It's a delicate balance, this nuclear fire holding up the weight of a star. But eventually the fuel runs out. The fire dies, and gravity wins. The core collapses. In a fraction of a second, matter that once occupied a volume larger than Earth compresses down to something the size of a city. then smaller still. The outer layers of the star rebound off this collapsed core and explode outward in a supernova, one of the most violent events in the universe. But the core continues to collapse. If it's massive enough, nothing can stop it. Not the pressure of electrons, not the resistance of neutrons, not any force known to physics. It collapses past any possible structure, past any possible size, until it becomes a singularity, a point of infinite density, a place where the known laws of physics break down completely. Around this singularity, space-time curves so severely that it creates a boundary, the event horizon. If you cross this boundary, all paths through space-time lead inward. You cannot turn around. You cannot escape. Even light, which always travels in straight lines through space-time, finds that all its straight lines point toward the center. The black hole doesn't pull light in like a vacuum cleaner. It warps space-time so thoroughly that inward becomes the only direction. From the outside, a black hole appears as a sphere of perfect darkness. Any light that crosses the event horizon is gone, swallowed into a place we cannot see or retrieve. And around this darkness, strange effects occur. Time slows down for objects near the event horizon, as seen from far away. Light from those objects gets redshifted, stretched toward longer, redder wavelengths. The fabric of space twists and drags, pulled along by the black hole's rotation if it's spinning. These are patient monsters, generally speaking. A black hole formed from a collapsed star might have a mass 10 or 20 times that of the Sun, but an event horizon only about 60 kilometers across. It sits in space invisible except for its gravitational effects, slowly accreting any matter that drifts too close. Gas spirals inward, heating up to millions of degrees as it accelerates, emitting X-rays that we can detect. This is how we find stellar mass black holes, not by seeing them, but by seeing the light from matter dying as it falls into them. At the centers of galaxies, there are black holes millions or billions of times more massive than the Sun. These supermassive black holes are even more patient. Their event horizons are enormous. The one at the center of our Milky Way galaxy would fit comfortably inside Mercury's orbit, but they grow slowly, accumulating mass over millions of years. They shape the galaxies around them, but they don't race through space. They sit like anchors, like hearts of darkness around which everything else orbits. So what would it mean for such an object to expand faster than light? Let's be clear about what's expanding. Not the singularity at the center. That's already infinitely small in the classical picture, and we don't really know what happens there because our physics breaks down. What expands is the event horizon, that boundary of no return. The size of the event horizon depends on the mass of the black hole. The more massive the black hole, the larger the event horizon. This relationship is simple and direct. The radius of the event horizon, called the Schwarzschild radius, is proportional to the mass. So for the event horizon to expand faster than light, the black hole must be gaining mass faster than light can outrun the growing boundary. It must be feeding so voraciously, so efficiently, that it swells outward at impossible speeds. But how? Where does all this matter come from? How can anything fall into a black hole fast enough to make its event horizon expand at such a rate? This is where we enter the realm of the extreme, the early universe, the moments just after the Big Bang when the cosmos was unimaginably dense and hot. In those first seconds, matter and energy were compressed into a space far smaller than it is now. Quantum fluctuations, random variations in density, were blown up to cosmic scales by inflation. Some regions were slightly denser than others, and where the density was high enough, gravity could create something truly strange. These are called primordial black holes. They didn't form from the collapse of stars, because stars didn't exist yet. They formed directly from the density fluctuations of the early universe, from regions where matter was compressed so tightly that it collapsed into black holes spontaneously. These black holes could have a wide range of masses, from tiny, smaller than an atom, to massive, thousands or millions of times the mass of the Sun. And in those early moments, they would have been surrounded by an ocean of matter. The universe was dense. Everything was close together. A black hole forming in such an environment wouldn't have to wait for matter to trickle in slowly over eons. It would be submerged in a bath of particles and radiation, all available to feed its growth. Imagine it, a black hole born in the first second of the universe. embedded in a plasma so dense that matter is everywhere. It begins to feed. As it consumes matter, it grows. As it grows, its event horizon expands. And because the universe itself is so dense, there's always more matter rushing in, more fuel for the fire. The event horizon swells outward, chasing the receding matter, but matter keeps falling in from all sides. In such an environment, could the event horizon expand faster than light? Could the infall of matter be so rapid, so relentless, that the boundary grows faster than photons can escape from its vicinity? The mathematics suggests yes. In principle, if enough matter falls into a black hole fast enough, the event horizon can expand at any speed, including faster than light. Because the expansion of the event horizon is really the expansion of a geometric property of space-time, not the motion of a physical object through space. It's similar to how space itself can expand faster than light. The event horizon is a feature of space-time geometry, and that geometry can change as rapidly as matter and energy allow. Of course, there are limits. The black hole can't feed faster than matter can physically fall in. And as matter falls in, it heats up, emits radiation, and that radiation exerts pressure that can push away additional matter. This is called the Eddington limit, and it represents a kind of natural speed limit on black hole growth under normal circumstances. If a black hole tries to accrete matter too quickly, the radiation from the infalling matter becomes so intense that it blows away the surrounding material, choking off the supply. But in the extreme environment of the early universe, perhaps things were different. Perhaps the density was so high, the pressure so immense, that matter had nowhere to go but inward. Or perhaps there are mechanisms we don't yet understand, exotic physics that operates in those extreme conditions, that allows for even more rapid accretion. This is where science reaches the edge of its map. We have equations, yes, we have models, but we don't have certainty. We can imagine a black hole whose event horizon expands faster than light, born in the chaotic first moments of the universe, gorging itself on the primordial soup of existence. But whether such a thing actually happened, whether it exists somewhere in the observable universe or perhaps beyond it, is a question we cannot yet answer. And perhaps that's appropriate. Perhaps some mysteries should remain mysteries, at least for a while. The universe doesn't owe us immediate understanding. It unfolds its secrets slowly, at its own pace, and we are simply fortunate to witness even a fraction of the story. So let's drift with this idea for a while. Let's imagine that somewhere in some distant corner of space-time, there is a black hole that defied the odds, a void that grew so rapidly in those first moments that its event horizon raced outward faster than light itself. What would that look like? What would it mean? From the outside, from a safe distance, you might not notice anything unusual at first. A black hole is a black hole, after all, a region of darkness, a gravitational well. But as you observed it over time, you might notice that it seems to be growing unusually fast. Stars and gas clouds that were far away yesterday are being swallowed today. The sphere of darkness widens, creeping outward like a slow stain spreading across the fabric of space. But if you were somehow able to measure carefully, to track the expansion of the event horizon precisely, you would discover something unsettling. The edge of the black hole is moving outward faster than light could travel away from it. Her photon emitted just outside the event horizon, trying to escape, would find itself overtaken by the expanding boundary, swallowed before it could get away. This is a strange kind of race. The photon isn't moving backward. It's still traveling at the speed of light, as it always does. But the space it's traveling through is being reshaped so rapidly that the destination, safety, the outside, is receding faster than the photon can reach it. It's like running on a treadmill that accelerates faster than you can keep up. You're still running forward, but you're going backward relative to the ground. Inside such a black hole, or rather near the event horizon, the geometry of space-time would be violently distorted. Time and space would intertwine in ways that are difficult even to imagine. Time might stretch or loop or fracture. Space might fold back on itself, creating closed paths that lead nowhere. Any observer caught in such a region would experience effects that defy description, partly because our language is built on the assumption of stable, predictable space-time, and partly because we don't fully understand what happens in such extreme conditions. But perhaps no observer could exist there. Perhaps the tidal forces, The difference in gravitational pull from one side of an object to the other would be so extreme that any structure, any atom would be torn apart long before experiencing these strange geometries, or perhaps the radiation, the sheer energetic chaos of matter falling in at such speeds, would disintegrate anything complex. We don't know. We can't know, not from direct observation. These regions are hidden from us behind the event horizon, causally disconnected from our universe. What happens there stays there. The black hole keeps its secrets, yet we keep thinking about it. We keep writing equations, building models, imagining, because that's what we do. That's what it means to be human, to be conscious observers in a universe that is so much larger and stranger than ourselves. We push against the boundaries of the known. We peer into the darkness and ask, what's there? And sometimes the darkness seems to ask back. There's a philosophical dimension to all of this beneath the mathematics and the physics. When we talk about a black hole expanding faster than light, we're really talking about the limits of knowledge itself. We are talking about boundaries that cannot be crossed, at least not without leaving behind everything we know. The event horizon is the ultimate one-way door. Information can go in, but it cannot come out, or at least that's what we've long believed. Stephen Hawking complicated this picture in the 1970s when he discovered that black holes aren't entirely black. Through a strange quantum effect near the event horizon, they emit radiation, now called Hawking radiation. Virtual particle pairs pop into existence all the time, everywhere in space, borrowing energy from the vacuum and then annihilating each other an instant later. But near the event horizon, one particle can fall into the black hole while the other escapes, and the escaping particle becomes real, carrying away energy. Over immensely long timescales, this process causes black holes to evaporate, but Hawking radiation raised a paradox. If the radiation is random thermal, it doesn't carry information about what fell into the black hole. So when the black hole eventually evaporates completely, where does the information go? Information, according to quantum mechanics, should be conserved. It can be scrambled, hidden, transformed, but never truly destroyed. Yet a black hole that evaporates via Hawking radiation seems to erase information permanently. This puzzle, the black hole information paradox, has occupied some of the brightest minds in physics for decades. Recent research suggests that information might be encoded in the Hawking radiation in subtle ways we don't yet fully understand. Or perhaps it's stored in the structure of the event horizon itself, in quantum correlations too complex for us to decode. The paradox may be dissolving, or it may be transforming into something even stranger. But if we add faster-than-light expansion into the picture, the questions multiply. Does such rapid growth affect Hawking radiation? Does it change the way information is processed by the black hole? Could a black hole expanding faster than light create regions where even theoretical predictions break down, where we can't even write consistent equations? These are the kinds of questions that make some physicists uncomfortable and others excited. They point to the edges of our theories, the places where general relativity and quantum mechanics intersect and sometimes contradict each other. We know that both theories are extraordinarily successful in their domains, general relativity for large-scale gravity and cosmology, quantum mechanics for the very small. But they don't play well together. At the event horizon of a black hole, especially an extreme one, both become important simultaneously, and we don't have a unified theory that fully describes what happens. This is one reason why black holes are so important to physics. They're not just exotic objects in space. They're laboratories, natural experiments where the universe pushes its own rules to the limit. By studying them, or at least by thinking carefully about them, we learn where our theories work and where they fail. And where they fail, that's where new physics waits to be discovered. So perhaps this black hole, this impossible thing that grows faster than light, is trying to teach us something. Perhaps it's showing us that our understanding of space, time, gravity, and light is still incomplete, that there are layers beneath what we know, deeper structures waiting to be revealed. Or perhaps it's simply a beautiful mystery, a reminder that the universe is not obligated to make sense to us. That reality can be stranger than our imaginations, more subtle than our mathematics. And that's okay. There's a kind of peace in that, a humility. We don't have to understand everything. We can simply witness, simply wonder. Let's think about what it means for something to be faster than light in a different way. Not in terms of physics, but in terms of perception, of meaning. Light has always been our messenger. It carries information from the world to our eyes, from distant stars to our telescopes. It's how we know anything about the universe beyond our immediate touch. In a very real sense, light defines the limits of our knowledge at any given moment. We cannot see beyond the light that has reached us, so when we imagine something expanding faster than light, we're imagining something that outpaces knowledge itself, a boundary that moves faster than information can travel. It's a kind of encroaching unknown, a shadow that grows not just in size but in epistemic weight. The black hole doesn't just swallow matter and energy, it swallows the possibility of knowing. And yet, paradoxically, by contemplating it, we've brought it into the realm of thought. We've made it an object of study, of imagination. Even if we can never observe such a black hole directly, even if the universe never produced one, the fact that we can think about it, model it, explore its implications, that itself is a kind of light. The light of consciousness, of reason, of curiosity. This is the dance between knowledge and mystery. We illuminate the darkness with our questions, and in doing so, we often find more darkness beyond deeper questions, stranger puzzles. But we also find beauty. We find connections between ideas that seemed unrelated. We find that the universe, in all its strangeness, has a kind of coherence and aesthetic elegance that suggests, what, purpose? Design? Or simply the inevitable structure that emerges from simple laws operating over vast scales of time and space? We don't need to answer that. Not tonight. Tonight we're just drifting, just wondering, just letting the ideas wash over us like starlight, like the gentle rhythm of waves on a distant shore. Let's shift our perspective for a moment. Let's think about the black hole not as a destroyer, but as a transformer. Everything that falls into it doesn't disappear from the universe. It becomes part of the black hole. Its mass, its energy, its angular momentum, if it was spinning, all of that gets added to the black hole's properties. In a sense, the black hole remembers what it consumed, even if the details are hidden behind the event horizon. And if this black hole is growing, expanding, swelling with the matter of the early universe, then it's also becoming a kind of archive, a repository of everything that was, compressed into a form we cannot read but that nonetheless exists. The first atoms, the first particles, the raw energy of the Big Bang, all folded into this singular darkness, preserved in a way, even as they're transformed beyond recognition. There's something almost poignant about that. The universe preserving its own history, inside an object that prevents any of that history from being observed. It's like a memory locked in a box that can never be opened, a story written in a language that burns the eyes of anyone who tries to read it. But maybe that's not quite right. Maybe the information isn't entirely locked away. Maybe through Hawking radiation or some other mechanism we haven't discovered, the black hole slowly releases its secrets back into the universe, scrambled and encrypted, but present nonetheless. Over unimaginable eons, as the black hole evaporates, it gives back what it took, particle by particle, photon by photon. The universe gets its memories back, though in a form so transformed that they might as well be new. This process would take longer than the current age of the universe by many, many orders of magnitude. We're talking about timescales that make billions of years seem like the blink of an eye. Black holes are patient. They operate on a timescale that dwarfs civilizations, dwarfs species, dwarfs the lifetime of stars. In the deep future, long after all the stars have burned out and the universe has grown cold and dark, black holes will be the last remaining structures, slowly radiating away their mass until they too dissolve into the void. But that's a different story, a different kind of twilight. Tonight, we're thinking about a black hole in its prime, in its moment of violent growth, fed by the richness of the early universe. A black hole that defied expectations, that pushed the boundaries of what we thought possible. Let's imagine we could somehow watch this process unfold. Of course, we couldn't, not really. It would have happened billions of years ago in conditions so extreme that no observer could survive. But let's imagine anyway. Let's use the gift of imagination to place ourselves safely outside the danger looking in. At first, there's only chaos. The universe is a fraction of a second old, and it's a seething foam of energy and nascent matter. Quarks and gluons zip around in a plasma so hot that atoms can't form. The forces that will later govern the universe, gravity, electromagnetism, the strong and weak nuclear forces, are still settling into their roles, still differentiating from the unified force that existed at even earlier times. In one small region, though small is relative, this region might be larger than our entire observable universe today. A fluctuation occurs, a random variation in density, the kind that happens naturally in a quantum system. Most fluctuations smooth out, average away, but this one is on the edge, right at the threshold where gravity can take hold, and it does. The region begins to collapse, to pull in on itself. Gravity, even in this strange early environment, is still gravity. It still pulls matter together. The collapse accelerates, and within an incomprehensibly short time an event horizon forms. A primordial black hole is born. But unlike the black holes that will form later from dying stars, this one is surrounded by an abundance of material. The universe hasn't expanded much yet. Everything is still dense, still packed together. Matter pours into the nascent black hole from all directions. Not gently, not slowly, but in a torrent, a deluge. The event horizon expands rapidly. The more matter that falls in, the more massive the black hole becomes, and the larger its event horizon grows. And because there's so much matter available, the growth doesn't slow down. It accelerates. The event horizon swells outward, overtaking more and more of the surrounding space. Photons are everywhere in this early universe, part of the primordial radiation that fills everything. They zip around at their constant speed, bouncing off particles, scattering through the plasma. But near this growing black hole, some of them find themselves in trouble. They're moving away from the event horizon, as fast as they can, but the event horizon is growing faster. The boundary catches up to them, overtakes them, and they cross over without even slowing down. One moment they're free, the next they're trapped, falling inevitably toward the singularity at the center. This is the race that light lost, not through any fault of its own, but because the rules of the game changed. The racetrack itself was shifting, expanding, moving the finish line farther away faster than light could run. How long could this continue? That depends on the environment. In the very early universe, the density was dropping rapidly as space expanded. Within seconds, the universe had expanded and cooled enough that the primordial plasma began to thin out. The black hole, no matter how voracious, would eventually run out of nearby matter to consume. Its growth would slow, and eventually settle into the more patient, more typical accretion we see in black holes today. But in those first moments, in that brief window when the universe was dense beyond imagining, a black hole could achieve things that seem impossible by later standards. It could expand faster than light. It could consume vast quantities of matter. It could grow from something microscopic to something with the mass of 1,000 suns, all in the blink of an eye, cosmically speaking, and then it would settle down. It would become just another black hole, drifting through the expanding universe, waiting for the occasional meal, slowly radiating away its mass over timescales so long that the numbers lose meaning. But it would remember. In some sense, it would carry within it the memory of that first violent moment, that impossible growth. Encoded in its mass, its spin, the subtle quantum information preserved in its structure. A fossil from the very beginning of time. If such black holes exist, we might be able to find them, or rather, we might be able to detect their effects. Primordial black holes, if they're common enough, could contribute to the dark matter that we know makes up most of the matter in the universe. They could be the unseen mass that holds galaxies together, that shapes the large-scale structure of the cosmos. We can't see them directly, but we could see their gravitational effects, the way they bend light from more distant objects, or the way they influence the motion of stars and gas. So far, we haven't found definitive evidence of primordial black holes. There are some intriguing hints, some observations that could be explained by their presence, but nothing conclusive. The universe keeps its secrets well, or perhaps we're not looking in the right way. Perhaps the signatures of these exotic black holes are subtle, hidden in the noise of our instruments, waiting for us to develop new techniques, new technologies, new ways of seeing, or perhaps they never existed at all. Perhaps the conditions required for such extreme growth never occurred, even in the chaotic early universe. Perhaps there are limits we haven't thought of, physical constraints that prevent event horizons from expanding faster than light, even in principle. We don't know, and in a way, that's the most exciting part. We stand at the edge of knowledge, looking out into the unknown, and we can imagine possibilities that we can't yet confirm or deny. We can dream of black holes that break the rules, that defy our expectations, that challenge us to think more deeply about the nature of reality. And whether they exist or not, the dream itself is valuable. It pushes us, it expands the boundaries of our thinking, much like those black holes might expand their event horizons. Each question we ask, each impossibility we contemplate, stretches our understanding a little further, reveals a little more about what we don't know. There's a concept in philosophy and science called the unknown unknowns. These are the things we don't even know that we don't know, the questions we haven't thought to ask yet, the phenomena that lie completely outside our current frameworks. They're the hardest kind of ignorance to address because we can't even see the gaps in our knowledge. But sometimes, by pushing ideas to their extremes, by imagining the impossible, we stumble into these unknown unknowns. We find questions we didn't know we should be asking. So a black hole that expands faster than light might be impossible, or it might be rare, or it might require physics we haven't discovered yet. But by thinking about it, we're forced to confront assumptions we didn't realize we were making. About causality, about the nature of space-time, about what it means for something to move. And that's how progress happens often. Not through steady, predictable advancement, but through these moments of confusion and wonder. When something doesn't make sense, and we have to rebuild our understanding from the ground up. Einstein didn't set out to prove that time was relative and space could bend. He was trying to resolve some small inconsistencies in the theory of electromagnetism, some strange results in experiments measuring the speed of light. But by following those threads, by refusing to accept the easy answers, he uncovered something far deeper. He revealed that space and time were not the fixed, absolute stage that Newton had imagined, but a dynamic, flexible medium that could be warped by mass and energy, and even Einstein resisted some of the implications of his own theory. When his equations suggested that the universe was expanding, he added a fudge factor, the cosmological constant, to keep it static, because a static universe was what everyone expected. It was only later, when observations confirmed the expansion, that he abandoned that addition, reportedly calling it his greatest blunder. But here's the interesting part. The cosmological constant has made a comeback. Modern observations suggest that the expansion of the universe is accelerating, driven by something we call dark energy. And one way to model dark energy is with a cosmological constant, the very thing Einstein introduced and then rejected. The universe has a sense of humor, it seems. The point is, our intuitions are often wrong. What seems impossible or ridiculous can turn out to be true. What seems obvious and necessary can turn out to be a special case, an approximation that works in limited circumstances but fails in the extremes. So when we imagine a black hole expanding faster than light, we should hold that idea lightly. It might be wrong. It might be based on a misunderstanding of what expansion means, or what the event horizon is, or how space-time behaves under extreme conditions. But it might also be pointing us towards something real, something profound, something that will reshape our understanding once again. The universe is patient. It will still be here, still mysterious, still beautiful, long after we've figured out this particular puzzle. And there will always be more puzzles, more mysteries, more whispers from the deep. For now, let's just sit with the strangeness of it. A black hole that grows so fast it outraces light. An event horizon that swells like a cosmic lung, breathing in the matter of the early universe, expanding outward in defiance of what should be possible. It's a powerful image, isn't it? Even if it's just a thought experiment, even if no such thing ever existed, the image itself has weight. It resonates. Maybe that's because it touches on something deeper than physics. The idea of a boundary that cannot be crossed, a point of no return, is deeply embedded in human psychology. We all face event horizons of a sort in our lives, decisions that once made cannot be unmade, moments that once passed change everything. The past is another country, separated from us by the one-way flow of time. We can remember it, reflect on it, learn from it, but we cannot return to it. And the future is an expanding unknown, racing away from us faster than we can catch up. No matter how fast we move, how much we accomplish, there's always more time ahead, more possibilities, more darkness waiting to be illuminated or accepted. A black hole expanding faster than light is, in this sense, a metaphor for the human condition. We chase understanding, we chase meaning, we chase light. But the universe of things we don't know expands faster than we can explore it. Every answer reveals new questions. Every horizon we reach reveals more horizons beyond. But that's not a cause for despair. It's a cause for wonder. We will never run out of mysteries. We will never know everything. And that's beautiful. It means there will always be something to discover, always something to think about, always something to draw us forward. The black hole doesn't care about our thoughts, of course. It exists, or might exist, utterly indifferent to our curiosity. It follows the laws of physics, whatever those turn out to be in the extreme conditions near its event horizon. It doesn't know it's strange. It doesn't know it's impossible. It simply is. And we, from our safe distance across billions of years and billions of light years, can contemplate it, can turn it over in our minds like a strange stone found on a beach, wondering where it came from, what forces shaped it, what stories it could tell if only it could speak. This is the gift of consciousness, of intelligence. We can reach beyond our immediate surroundings, beyond our own survival, and touch the furthest edges of reality with our thoughts. We can ask questions that have no practical value, that don't help us find food or shelter or mates, but that satisfy something deeper. A hunger not of the body, but of the mind, of the spirit. And in asking those questions, we become part of the universe's attempt to understand itself. We are, each of us, a way for the cosmos to know itself, as Carl Sagan beautifully put it. When we think about black holes or quantum mechanics or the origin of the universe, we're not separate observers looking at an alien object. We are the universe, a small part of it that has become conscious and curious. The atoms in your body were forged in the cores of stars, the iron in your blood, the calcium in your bones, the oxygen you breathe, all created in nuclear furnaces billions of years ago, then scattered through space when those stars exploded, eventually coalescing into the planet we live on. You are literally made of stardust, and now that stardust has organized itself into a form that can wonder about black holes, about the speed of light, about the nature of existence. Isn't that extraordinary? Isn't that worth pausing to appreciate? You are the universe thinking about itself. And tonight, you're thinking about one of the strangest things the universe might contain, a black hole that expands faster than light, a void that races outward through space-time, swallowing everything in its path, growing beyond all expectation. It's a dark thought in a way, a hungry darkness consuming the light. But it's also a thought about growth, about transformation, about the extreme limits of physical law. And there's something almost vital about it, something alive in that hunger, that expansion. Black holes are often portrayed as cosmic villains, as destroyers, and they do destroy in a sense. They tear apart stars, swallow planets, crush matter down to incomprehensible densities, but they also create. They shape the galaxies around them. The supermassive black holes at galactic centers regulate star formation, control the flow of gas and dust, determine the structure of their host galaxies. Without black holes, galaxies would be very different places. Perhaps life would be less likely or impossible. And in a deeper sense, black holes represent the ultimate alchemy. They take matter and energy and transform it into something else, something hidden, something mysterious, but something that still exists. The mass doesn't disappear from the universe. It becomes part of the black hole. And eventually, through Hawking radiation, it might be returned, transmuted beyond recognition, but present nonetheless. So perhaps this rapidly expanding black hole, born in the first moments of creation, gorging itself on the primordial plasma, isn't a villain. Perhaps it's a midwife or a gardener or a recycler. Perhaps it's part of the universe's way of organizing itself, of distributing energy, of creating the structures that will eventually allow stars and planets and life to emerge. We tend to anthropomorphize, to assign intentions and roles to things that simply follow natural law. The black hole doesn't choose to expand or consume. It's not hungry in any conscious sense. It simply obeys the equations, responds to the matter and energy around it according to the rules of general relativity and quantum mechanics. But our human habit of storytelling, of finding narrative in natural processes, isn't entirely wrong. It helps us connect with these abstract concepts, to make them meaningful. And in a universe that is fundamentally mathematical, fundamentally governed by impersonal laws, meaning is something we bring to the table. It's our contribution, our way of participating in the cosmic story. So let's tell the story. Let's imagine this black hole as a character in the grand drama of cosmic evolution, born in chaos, feeding on the richness of the young universe, expanding at impossible speeds, challenging the supremacy of light itself. And then, as the universe expands and cools, settling into a quieter existence, drifting through the eons, a relic of a more extreme time. Perhaps it's still out there somewhere, this black hole. Perhaps it wandered through the universe for billions of years, occasionally encountering gas clouds or stars, adding to its mass, but never again experiencing the voracious growth of its youth. Perhaps it's at the center of a galaxy now, mistaken for an ordinary supermassive black hole, its exotic origin hidden by the passage of time, or perhaps it evaporated long ago, giving its mass back to the universe in a slow rain of Hawking radiation. Or perhaps it was torn apart in a collision with another black hole, merging into something even larger, losing its individual identity, but contributing to the ongoing dance of gravity and space-time. We can imagine these possibilities because we can't observe them. The past is hidden from us, the deep past even more so. We can see the cosmic microwave background, the afterglow of the Big Bang, and from it we can infer a great deal about the early universe. But the very first moments, the first fractions of a second, are beyond our observational reach. We can only model them, simulate them, extrapolate from what we know. And in that space of uncertainty there's room for wonder, room for stories, room for black holes that defy expectations. Let's think about the nature of stories for a moment. Every culture, every civilization has told stories about the sky, about the cosmos. The stars were gods or heroes or animals or campfires of the ancestors. The Milky Way was a river or a road or spilled milk from a goddess's breast. These stories weren't true in a literal sense, but they were true in a deeper way. They connected people to the cosmos, made the vastness overhead meaningful, wove the sky into the fabric of human life. Modern science tells a different kind of story, one based on observation and mathematics rather than metaphor. But it's still a story. It's our culture's way of making sense of the universe, of finding patterns and meaning in the data our instruments collect. And it's a beautiful story, full of drama and strangeness. The story of a black hole expanding faster than light is part of that larger narrative. It's a tale of extremes, of boundaries pushed and perhaps broken. It asks us to think carefully about what we mean by motion, by speed, by the nature of space-time itself. And in wrestling with those questions, we deepen our understanding, or at least our appreciation for the complexity of reality. But unlike the ancient stories, modern science remains tentative. We hold our conclusions lightly, ready to revise them when new evidence appears. We know that our current theories, as successful as they are probably not the final word. General relativity and quantum mechanics work brilliantly in their respective domains, but they can't both be fully correct as currently formulated, because they give different answers in situations where both should apply. Somewhere, there's a deeper theory waiting to be discovered, a theory that unifies gravity with the other forces, that explains what happens at the singularity of a black hole, that resolves the paradoxes and inconsistencies. It might be string theory or loop quantum gravity, or something we haven't imagined yet. And when we find it, it will probably reveal that some of the things we thought were impossible are actually possible, and some of the things we thought were mandatory are actually special cases. The black hole expanding faster than light might be a clue pointing toward that deeper theory. Or it might be a red herring, a misunderstanding based on incomplete knowledge. Time will tell. Or rather, scientists will tell, through patient observation and careful thought, building on the work of those who came before, inching closer to a fuller picture of reality. And in the meantime, we can wonder. We can imagine. We can let these ideas drift through our minds like clouds across a summer sky, shape-shifting, beautiful, ephemeral. Think about the word event horizon for a moment. An event is something that happens, a point in space-time. The horizon is the boundary of what you can see. The event horizon of a black hole is the boundary of what can happen in the observable universe from your perspective. Beyond it, events occur, but they can never affect you, never send you signals, never be witnessed. It's a kind of cosmic censorship. The universe hides its most extreme physics behind these boundaries, keeping the singularities and the breakdowns of law out of sight. Some physicists have even proposed a cosmic censorship hypothesis, suggesting that the laws of physics actively prevent naked singularities, singularities without event horizons, from forming. It's as if the universe has a sense of modesty, or perhaps a concern for its own consistency. But the event horizon itself is not a physical barrier. It's not made of anything. You could cross it without feeling a thing, at least for a large enough black hole where the tidal forces at the horizon aren't lethal. One moment you're outside, able to send signals to the rest of the universe. The next moment you're inside and all your signals point inward, toward the singularity. The transition is smooth, inevitable, and one way. And if the horizon is expanding faster than light, then this transition is chasing outward through space, converting regions of normal spacetime into interior of black hole spacetime. It's a kind of phase transition, a boundary between different states of geometry propagating outward. We see similar things in other contexts. When water freezes, the boundary between ice and water propagates through the liquid. When a sound barrier is broken, a shock wave expands outward. These are simpler, more familiar processes, but they share a family resemblance with the expanding event horizon. Her boundary moving, a transition spreading, changing the nature of the space it passes through. Of course, the expanding event horizon is far more exotic. It's not just a change in the state of matter, but a change in the structure of space-time itself. And it's not breaking a barrier, but rather expanding a region from which there is no escape. If you were outside such a black hole, watching it grow, you would see. Actually, what would you see? This is an interesting question. Light from the event horizon can't reach you. That's what makes it an event horizon. But light from the region just outside can, though it would be redshifted, stretched to longer wavelengths by the intense gravity. You would see a sphere of darkness. Yes, but around it, there would be distortions. Light from stars behind the black hole would be bent, creating a ring of warped images. This is called an Einstein ring, and we've observed them around massive objects that bend light. The black hole's gravity acts like a lens, focusing and distorting the light from more distant sources. As the black hole grows, this ring would expand. The sphere of darkness would swell outward, swallowing more and more of the sky from your perspective. If you were close enough, and if the black hole were growing fast enough, you might see this happen noticeably over a short period. The darkness spreading, the distortions shifting. But you wouldn't see the event horizon itself expanding faster than light, because you see things via light. What you'd observe would be limited by the speed at which light can reach you. The expansion might be faster than light in the black hole's local frame, but your observation of it would still be mediated by photons traveling at their usual speed. This is one of the subtleties of faster-than-light phenomena in general relativity. What faster than light means depends on your frame of reference, on how you're measuring distance and time. In a curved dynamic spacetime, you can have situations where something seems to move faster than light in one sense, but no information or causality actually propagates faster than light in the local frame. It's a bit like the expansion of the universe again. Distant galaxies are receding from us faster than light due to the expansion of space, but that doesn't mean they're moving through space faster than light. Space itself is expanding, carrying them along, and we can't use this expansion to send signals faster than light. The recession doesn't allow communication. Similarly, an event horizon expanding faster than light doesn't mean you could use it to send information faster than light. In fact, you can't send information out of a black hole at all, by definition. The expansion is a change in geometry, not a signal, but it's still mind-bending. It still challenges our intuitions, and that's valuable. Our intuitions were built for a world of moderate speeds, moderate scales, moderate energies. They're not well suited to the extremes of the cosmos, to speeds approaching light, masses concentrated into singularities, or the quantum fuzziness of the very small. By contemplating these extremes, we calibrate our intuitions, or perhaps we learn to mistrust them in the right contexts. We learn that what seems obvious isn't always correct, that the universe is under no obligation to match our expectations, and we learn humility. We're clever, yes. We've figured out a remarkable amount about the cosmos, considering we're just barely intelligent apes on a small planet, orbiting an average star in an ordinary galaxy. But there's so much we don't know. So much we can't know, maybe, and that's okay. We do our best. We build our instruments, we develop our theories, we test and refine and occasionally revolutionize our understanding. And all the while, The black holes continue their patient work, whether we understand them or not. The one that might have expanded faster than light if it ever existed is long gone or long settled into quiet maturity. It doesn't need our understanding. It simply is, but we need to understand, or at least we need to try. It's part of what makes us human. The curiosity, the drive to know, the refusal to accept mystery without at least asking questions. We might not get answers. The universe might remain silent, might keep its secrets, but we'll keep asking anyway. And sometimes the asking itself is enough. The process of inquiry, the community of scholars and thinkers working together across generations, building on each other's insights, correcting each other's errors, that's a beautiful thing. It's one of humanity's better qualities, this collaborative pursuit of knowledge. We stand on the shoulders of giants, as Newton said, though he was being a bit backhanded when he said it. Every scientist today builds on the work of countless others, from ancient astronomers tracking the planet's motions, to medieval scholars preserving and translating Greek and Arabic texts, to the revolutionaries like Copernicus and Galileo and Newton and Einstein, who reshaped our understanding. And it continues. Right now there are researchers analyzing data from gravitational wave detectors, trying to understand the collisions of black holes across the universe. There are theorists working on the equations of quantum gravity, trying to build a framework that might explain what happens at the singularity. There are astronomers searching for primordial black holes, looking for the subtle signs that might reveal their presence. Maybe one of them will find something that relates to this idea of faster-than-light expansion. Maybe they'll find evidence that supports it, or definitively rules it out. Or maybe the question will remain open for decades, for centuries, waiting for the right technology or the right insight to resolve it. Either way, the quest continues. The story unfolds, and we're privileged to be part of it, even if our individual contributions are small. Even if all we do is wonder, that's enough. We're part of the universe wondering about itself, and that's a role worth playing. Let's drift back to the image of the black hole itself, that expanding sphere of darkness. Let's think about what it represents beyond the physics. Darkness has always been mysterious to humans, both frightening and comforting. The darkness of night is when predators hunt, when we're vulnerable, when we can't see dangers approaching. But it's also when we sleep, when we rest, when we dream. It's a time of quiet, of peace, of restoration. The darkness of a black hole is different. It's not the absence of light due to lack of illumination. It's the impossibility of light escaping. It's a fundamental darkness, a feature of space-time geometry. And yet, metaphorically, it shares something with the darkness of night. It's a place of mystery, of hidden things, of transformation. When you sleep, your conscious mind goes dark and the unconscious takes over. Dreams bubble up from depths you can't access while awake. Memories are consolidated, emotions are processed, your body repairs itself. You emerge from sleep transformed, refreshed, ready for a new day. The darkness was necessary. Perhaps black holes serve a similar function for the universe. They take matter and energy that have become too concentrated, too entangled, and they hide it away, process it in ways we can't observe, and eventually, over unimaginable timescales, release it back in a new form. The universe's way of sleeping, of dreaming, of transforming. This is a poetic thought, not a scientific one. But poetry and science aren't enemies. They're different languages for approaching truth, for finding meaning. Science gives us precision, predictive power, a framework for understanding how things work. Poetry gives us resonance, emotional connection, a framework for understanding what things mean. We need both. A universe described purely through equations is sterile, disconnected from human experience. A universe described purely through metaphor is vague, unanchored from testable reality. But together they create a richer picture, one that satisfies both the mind and the heart. So yes, let's think of the black hole as a dream of the cosmos, a strange, dark dream born in the violent early moments, expanding faster than light itself, consuming the primordial chaos, growing into something vast and patient. And now, billions of years later, we've dreamed it into our own consciousness, pondered its existence, explored its implications, the dream within the dream, the universe dreaming of its own dreaming. There's a recursive quality to consciousness that mirrors the strange geometries of black holes. You can think about your own thoughts. You can be aware of your own awareness. You can question your own questioning. It loops back on itself, creating a kind of infinite regress that somehow doesn't collapse, but instead generates the rich inner life of the mind. Philosophers have wrestled with this for millennia. What is consciousness? What is the self? How does mere matter, following the laws of physics, give rise to subjective experience, to the feeling of being someone, of experiencing qualia, of having an inner life? We don't have good answers yet. We know a lot about how the brain works, about neurons and synapses and neurotransmitters. We can map which regions are active during different tasks, track the flow of information through neural networks. But the hard problem of consciousness, why and how this physical process gives rise to subjective experience, remains unsolved. Maybe it's not solvable in the usual scientific sense. Maybe consciousness is a fundamental feature of reality, like space or time or energy. Or maybe we're just missing a key insight, a conceptual breakthrough that will make it all click into place. In the meantime, we have this strange gift. We are conscious. We experience. We feel, we think. And we can turn that consciousness toward the cosmos, toward the deep questions, toward black holes expanding faster than light. And in doing so, we participate in something larger than ourselves. We join the ongoing human conversation about the nature of reality, a conversation that spans cultures and centuries. That connects us to everyone who has ever looked up at the stars and wondered, you're part of that lineage. Right now, thinking about these ideas, you're part of a tradition that includes Aristotle and Hypatia, Galileo and Kepler, Einstein and Hawking, and countless others whose names are lost to history, but whose observations and thoughts contributed to the pool of human knowledge. That's something worth appreciating. In the grand scheme of the cosmos, human civilization is fleeting. We've existed for a tiny fraction of the universe's age, and we'll probably be gone, or transformed into something unrecognizable, long before the universe ends. But while we're here, we can do this. We can think. We can wonder. We can try to understand. And even if we fail, even if the universe's deepest secrets remain forever beyond our grasp, the attempt itself is meaningful. It's an expression of the cosmos's complexity, its creativity, its tendency to generate structures that can reflect on their own existence. You are that reflection. You are the universe looking at itself in the mirror and asking, what am I? How do I work? Why am I here? The black hole doesn't ask these questions. It exists without self-awareness, without curiosity, without wonder. But you do. And that makes you, in a sense, more complex, more remarkable than any black hole, no matter how massive or exotic. Of course, that's a subjective judgment. From a purely physical perspective, you're less extreme, less energetic, less influential on space-time than a black hole. But from the perspective of consciousness, of meaning, you have something the black hole lacks, the ability to care, to wonder, to find significance. Out there, past the roofs and trees, past the quieting streets, there is a deeper silence. It stretches between stars like the surface of a lake in winter, glossy and still. And in that vast calm there is a whisper. Not a sound in the way we know sound, but a slow pattern, a rhythm that appears when you look for long enough. Astronomers sometimes find it in the numbers, in the way the signals come and go, in the patient sweep of detectors tuned to catch light that left its home long before our species had a name for itself. The whisper is not words. It is more like a gesture, more like a steady pulse in the vastness, a suggestion that something in the dark is breathing. Imagine drifting closer to it. You are carried and you don't need to move. The whisper deepens the way a nighttime river deepens around its bends. Down in that soft darkness a shape grows. You might not see it at first. It doesn't glow. It doesn't scatter light. It is known by what it takes away. The way a missing piece tells you the shape of what once was there. You notice the way starlight curves, the way time itself seems to lean. You notice a border, not a wall, but a threshold, and beyond it the world you know cannot follow. This is a black hole, but not the still, simple kind we imagine from drawings. This one has a rhythm, a slow heartbeat, and watchers who have looked long and quietly speak of its edge expanding in a way that seems to outpace light itself. You don't need to decide whether that can be. For now, lean into the idea the way you lean into a warm wind. On a winter night, when the air is clear and the dome of the sky is a polished bell of darkness, our instruments listen. They listen to the hum of distant gas clouds and the crackling sigh of radiation that has traveled across an evolving universe. In that listening with patience and care, patterns appear. The edge of a black hole, the event horizon, is a kind of breathing boundary. It grows when the black hole feeds. It grows when space itself swells. And in certain ways of seeing, in certain frames where space flows like a river, the edge can seem to move faster than light's own step. If that sounds like a challenge to what you've learned, you can let it rest like a mystery on your pillow. There are places where speed is not quite what we think it is. There are currents that carry everything along, and sometimes the fastest thing is not a thing at all, but the widening of the stage on which all things move. Light has always been our messenger. Since the first creatures looked up and saw the glimmer of stars reflected in a pool, light has written its history on the night. It leaves bright marks in telescopes, thin lines in spectra, quiet letters that patient eyes can read. It carries the story of the sun to the skin on your cheek. It crosses a living room and turns dust into glitter in the late afternoon. In the deep light balances on a ridge of impossibility, moving so quickly that nothing else outruns it. That speed is not just a number. It is a limit woven into the fabric of how space and time hold hands. And yet, there are ways to step around the edge of that rule, not by breaking it, but by changing the rules of the game. If the board itself stretches, then the pieces drift apart faster than any of them can run. No piece has broken the law, and yet the space between is wider than light can bridge. You can picture it like this. You are standing on a raft. The river beneath you moves. If you toss a leaf forward as hard as you can, it may still drift backwards because the current is strong. It isn't that the leaf has failed. It's that motion here is measured against a floor that slides. Now imagine that the river sometimes swells and sometimes narrows, and the places where it widens press outward with a speed that no oar could match. No leaf is racing faster than it should. It's the river itself that moves. In a universe like ours, space can swell. In the first moments after the beginning, that swelling was so rapid that regions pulled away from one another faster than light could tie them together. The night we see now is like a fossil of that first breath. Some black holes preserve a similar rhythm at their edges, a way in which space is pulled in, and the twisting of time grows deeper. And in that twining, light slows and borders soften, and a horizon moves in a way that makes language reach for new metaphors. You don't need to hold all the details. If you prefer, think of a heart. Not a rushing heart, but a slow, deep beat. With each breath, the horizon seems to inhale starlight and exhale mystery. The fabric of space leans inward, and the boundary expands to meet it. It is a gentle tide, more patient than any ocean. A distant star strays too close, and its outer layers drift away like silk being pulled through a ring. Those filaments spiral inward, sending a warm sigh of radiation outward. Not much noise, not much drama, just the quiet exchange of energy, the simple arithmetic of gravity and time and the edge which listens and swells. Once, photons ruled our sense of the cosmos. We measured by their steps. We mapped by their directions. In the long darkness after sunset, with a simple telescope on a hill, you can feel how trustworthy light is. You aim, you gather, and you see. But near the darker hearts of the universe, light loses that old advantage. Not because light slows, it doesn't, but because the ground beneath it changes. When a black hole is quietly voracious, feeding on the faint dust that drifts toward it, on the whisper-thin winds from nearby stars, its horizon can grow in a way that makes the word speed blur at the edges. Out on the boundary, you might imagine the shadow running outward quickly, the way a shadow seems to leap across a field at twilight, not because the sun moves quickly, but because the line between day and night is painted by geometry more than by motion. In the same way, the edge of a black hole can race not as a thing moving in space, but as a change in what counts as outside and inside. Imagine the birth of such a thing. Not all black holes are born from dramatic explosions. Some materialize from quiet collapse, the way a heavy quilt slowly surrenders to its own weight and pools into a darker shape. A star spends its life holding itself up, fusing the lightest elements into heavier siblings and releasing energy as it does, a brightness that pushes outward. That outward push is a kind of soft voice saying, "Stay," to the inward tug of gravity. When the voice grows tired, when the fuel is spent, gravity clears its throat and continues speaking without interruption. The core shrinks. The atoms push back but are overruled. The star's heart falls inward and becomes dense in a way that is difficult to picture. A teaspoon heavier than mountains, a city crushed into a hush. In that hush, something simple emerges, a hole in the book where the pages have been pulled tight. There is an old story of a physicist traveling by ship, looking at the swell of the sea and thinking about how stars end, about the balance point, about what holds and what yields. While others paced the decks and watched waves break into pale foam, he worked in the quiet, pencil on paper, drawing the algebra of sacrifice. It turned out that for stars above a certain weight, no pressure could resist forever. Nobly, quietly, gravity would win. Not cruelly, just steadily, the way water flows downhill or the way the evening follows day even in the most stubborn summer. In that inner fall the event horizon forms, not as a surface you could touch, but as a boundary laid out by the rules of the universe, a limit on where light can go. Outside, light can still escape. Inside, it cannot. The line that separates those fates is not hard. It is a gentle seam sewn into space. If you watched for a long time, patient as moss-absorbing dew, you would see that seam drift outward when the black hole takes in more mass. With each addition, the geometry of space adjusts, the rules redraw the border, and the horizon breathes a fraction wider. In the depths of a young universe, there were moments when clumps of matter were so tight and so intense that black holes could form almost immediately, like seeds pressed into warm soil. If any of those ancient seeds survived to this night, very far away, they might still remember the rhythm of that first swelling, when space was not quiet, but rippling with the remnants of a beginning. In the hum we sometimes detect, that old rhythm murmurs. From our small place, it's easy to imagine destruction when we hear the phrase black hole, but the truth is calmer. Most of space is empty. Most nights nothing dramatic happens. Galaxies turn slowly, their spiral arms like the faint gestures of dancers seen through a veil. In the cores of some of those galaxies, darker anchors hold the whole together. They are not monsters. They are simply the resting places of mass and time. When bits of gas and dust wander near, they warm. They glow in soft X-rays and radio waves, which is just another way of saying they sing in ranges our dark-adapted eyes cannot hear. That singing can be measured, and through it we read the pulse of the horizon, the way it inhales matter and exhales geometry, the way its boundary steps outward, sometimes so quickly in our charts that we write numbers that surprise even the patient, seasoned minds who write them. Maybe you like to sit outdoors at night. You bring a cup of tea, watch it steam faintly in the cooler air and tilt your head back until the world widens. Bats flicker past. A satellite glides like a soft stitch across the sky. You can imagine the light pouring past the earth, photons racing by, indifferent to the slow revolving of our little world. Somewhere, unimaginably far away, a star is too close to a darker neighbor, and the neighbor is hungry, which here only means it is following the rules it cannot break. A tide forms. The star stretches and a spill of gas becomes a thin stream winding inwards. The stream heats as it circulates. It shines in disciplines beyond our eyes. We build ears for those tones. Dishes, mirrors, wires that chill to near absolute stillness so they don't confuse themselves with their own warmth. Into those quiet instruments the universe whispers. You could fall asleep to that whisper. Many have in observatories around the world, nestled into a chair as data scrolls, trusting that the signals will keep arriving. The way you trust your breath to keep moving. When light seems to lose the race, something interesting happens to time. Not to time as a ticking of a clock, not to the seconds that mark your day, but to the deeper arrangement that makes past and future, cause and effect, the familiarity of before and after. Close to the event horizon, time dilates. That is a shy word for stretches. A clock runs more slowly there compared to a clock far away. If you were to watch a friend fall toward the horizon, and we will keep this as thought only, calm as a math problem, they would seem to slow, to drift in a honeyed motion, never quite crossing the border. But from their point of view, nothing special happens at the crossing. This is one of the universe's little jokes, and we repeat it softly, because it has been told many times and still retains its quiet charm. Different places carry their own time inside them, like different rooms carry their own light. Near the horizon, the room is dimmer. That's all. And the combined effect of all those rooms with all their lights makes the night we live in which clocks are local, and the truth is wider and your own sense of time here and now, filled with your breath and the slow hush of your thoughts, is just as real as any faraway measure. There are ways of describing black holes that can make them friendlier to imagine. One is to think of space as a river flowing inward. Far from the black hole, the river glides slowly. It is as if you could paddle upstream with ease. The closer you get, the faster the river flows. At the horizon, the river goes as fast as light can swim. Inside, it goes faster still, and nothing can work against it. In this picture, nothing is moving through space faster than light any more than a leaf is outrunning a current. It is space that is carrying everything along. By this picture, the phrase faster than light belongs to the river rather than the leaf. That's the current that quickens. And the horizon, it is simply the place where swimming upstream is no longer enough. On a quiet night in a small lab, a graduate student once told me that thinking of the river helped her sleep. She would imagine floating, not resisting, letting the current take her. There was no fear in it, only acceptance, the way a nap finds you on a warm afternoon and you don't argue. She trusted that if the universe built such a river, it also built a way to admire it from a safe shore. We do. From here, light from the edge reaches us and we can reconstruct the flow. We can see the warm glow of infalling gas, the flickers as magnetic fields twist, the rhythm of emissions as matter spirals inward. And from these, slowly, we whisper back an understanding that the event horizon breathes, that its edge moves outward sometimes with a speed that would be scandalous for anything else, but is simple and lawful for a boundary in a changing geometry. If you like, imagine an orchard at night. The trees are dark silhouettes. Between them, mist clings low and silver. You walk slowly, and the world is a sequence of gentle surprises. A moth, a careful branch, the soft shape of fruit you can smell but not see. Between tree trunks, you glimpse a big dark at the center, where nothing grows. You don't need to enter to know it's there. You know it by the way the branches lean away from it, the way the ground dips, the way the air cools. A black hole is like that hollow in the orchard. Even before you see anything, the world around it shapes itself in response. Stars move differently. Gas is warmed in specific ways. Time itself bends a fraction. And from those cues we can tell the hollow's presence, and we can measure how it changes. The orchard takes a long, slow breath. The hollow stays the hollow. The air shifts gently around it. There are also equations, but tonight they can remain at the edge of our vision like distant mountains at dusk. They are there, beautiful in their way. A set of quiet lines that tell a long story. Some of those lines came to us during somber times, scribbled on paper by a man at the front of a war, looking up at the same moon we see now and sending a puzzle back to a colleague not knowing how the world would change. Some were polished on train rides in winter, on boats crossing wide oceans in rooms that smelled of chalk and coffee. Many were wrong, and then they were less wrong, and then less wrong again. The universe has been patient with us, allowing us to approach and retreat, to think we understood and then realize the horizon had moved, expanding to include subtleties we had missed. It is forgiving. It lets us nap and return, and it is still there when we open our eyes. Perhaps you are already drifting. That's all right. The story will remain even if parts of it become a gentle blur. The idea worth holding is no more complicated than the tide. There are places where the universe leans inward on itself. Those places are not flaws. They are part of the total weave. In them, boundaries are set by rules that favor patience over speed, curves over straight lines, currents over races. In those places, light seems to lose not because it is slower, but because it is running on a treadmill that itself is moving. And as mass falls inward and the geometry deepens, the treadmill grows. To us far away, measuring from a steady floor, that growth can look like something exceeding the speed limit. But what's really happening is a change of what limit means. The way a lullaby changes the meaning of time in a room where a child sleeps. The minutes are the same length, but they feel different. The thresholds are unchanged, but their gentleness is more noticeable than their firmness. It is also true, in a soft whispered way, that some black holes might have been born not from dying stars, but from the early universe's dense foam. Back then, before galaxies curled their arms, the energy of the universe was everywhere like a fog. In that fog, little fluctuations, tiny random differences, were amplified by the overall swelling. Where the fog was slightly denser, gravity tugged a little more, and those places could collapse quickly, forming black holes that were ancient even when the first stars blinked awake. If such ancient ones still move through the night, they are not hostile. They are simply older, like stones along a path worn smooth. And if one of them grew and grew again by gentle degrees, its horizon might now be as broad as a small solar system, and the way it changes could be felt as a subtle note in the symphony of background light. That background, The afterglow of the early universe is itself a whisper. We tune instruments to its coolness. We map tiny temperature differences across the sky that are small enough to be like the difference between the warmth of your breath on one hand and the air on the other. In those maps we see the seeds of everything. Galaxies, clusters, voids where little formed, and perhaps the first places where gravity tried the experiment of making a hollow so deep that even light could not climb out. The rhythm of the black hole's breathing could be a kind of memory of that original expansion, inhaling the past and exhaling shape. It is a romance to say so, but romance has rarely hurt science. Many careful minds were led to their exact work by a poetic thought, the way a single scent can call you back to a childhood room without asking for any logic to explain itself. Once, sitting on a wooden bench outside a small observatory, while coffee steamed weakly in the cold air, an older astronomer told me that the universe loves thresholds. He spoke slowly, his voice like a well-worn scarf. Not just event horizons, he said, but all thresholds. The edge of the land where the ocean begins, the place in the sky where blue deepens into black, the moment when you are half awake, half asleep. He believed that knowing how to stand gently on a threshold, without insisting on crossing too quickly, without demanding certainty, was as important in science as it was in life. We have built many instruments to measure horizons, and in doing so, we have learned the art of lingering at edges. We look not to conquer, but to witness. And at the edge of a black hole, we witness the simplest geometry, the steady widening of a boundary as the world settles around it. There is another gentle idea to cradle. Nothing about this is wrong or broken. Light is still the fastest messenger. The limit is not violated. When something seems to grow faster than light, it is the space between that widens, or the border that redefines itself. In our own days, we experience something like it. You might notice that a shadow can sweep across a wall faster than any object could move, or the spot where a beam of a lighthouse touches the clouds can move across the distance more quickly than any bird could fly. No bird is outrunning the rules. The rules are simply being asked a different question. The edge of a black hole can be like that, a moving idea rather than a moving thing. In this gentle clarity, confusion softens into a smile. The universe remains itself, and we are allowed to rest. Beyond Einstein's map, beyond our best charts of the curve of space and the gentle slowness of clocks, there is always a margin where the pencil did not quite reach. We are not embarrassed by that. It is a kindness. It means there will always be a reason to sit up late with tea, or to nap in an observatory chair while the computer listens for you, to wake and find that the data has written a phrase you have not read before. The margin is where we walk in twilight. It keeps us curious without letting us be frantic. In that margin, a black hole can be more than a number. It can be a quiet, breathing thing, a waypoint in the universe's larger story of expansion and coolness, and the making of complexity, and the gentle letting go of that complexity into simpler states again. Think of all the forests and cities and oceans that have come and will pass, and then think of the vote they all cast, in the end, for the deepening of the geometry that holds them. Gravity is not a tyrant. It is a patient archivist keeping accounts. If you are awake, notice your breath. If you are drowsy, let your breath notice you. There is a rhythm to the world that is no more dramatic than this. Into that rhythm we place the black hole's heartbeat. Slow, reliable, a boundary caressed outward by what it receives. No race, no victory. Just the way a quiet lake grows larger when rain falls, and no one says the lake is running fast. The water arrived. The shore adjusted. Everything remained in harmony. With black holes the horizon adjusts, sometimes quickly by our measures because our measures are human and short. The universe's measures are older and kind. They allow for swiftness in the language of borders without any need for alarm, and so we listen, and the whisper continues. It is the whisper of numbers that bulge slightly, of graphs that rise and fall like a sleeping animal's flanks, of tiny variations in background light that suggest a story told over eons. It is the whisper of starlight strained through the geometry of a deep well, of time that stretches and folds, of a universe that spends most of its energy not in explosions, but in long, steady balances. If at times it seems that light has lost a race, remember that there was never a race to begin with. Light is more like a guest who always arrives precisely on time for a gathering in a house with many rooms. Sometimes the host moves the walls, and the guest has farther to walk to reach the same chairs. The guest is still punctual. The rooms are simply different. In the quiet of your room, in the quiet of this moment, in the hush that draws around your shoulders like a shawl, imagine the countless horizons breathing. Not only the horizons of black holes, but the softer thresholds close to you, the doorway where you pause before entering a new day, the window where light is muted by curtains, the line between a waking thought and a drifting dream. These are not frightening lines. They are invitations. They say, you may cross if you like, or you may rest here and feel the slight change in the air. The universe is full of these gently shifting borders. It has always been so. And somewhere very far away, a dark heart that never truly beats is widening its grace again, accepting another thread of warmth and exhaling mystery into the space that supports it all. When you are ready, we will wander further, into that deeper current beneath reality, where speed is a different word, and time can be considered again with patient eyes. For now, let the whisper of the cosmos curl like smoke and fade. If you drift, you are in good company. The stars have been drifting for a long time. They are experts. They can keep the watch while you rest. And if a question remains, about light, about limits, about edges that move faster than you thought possible, let it remain a question, soft and spacious, like a gentle hollow in an orchard at night. I will be here, and the universe will be here, and together we will listen to the quiet, patient breath of the dark. The whisper of the dark has a way of finding patient minds. In a snow-lit city a century ago, a man with a familiar moustache drew lines on paper that reshaped the way we speak about space and time. He was not chasing spectacle. He was chasing consistency, a gentle alignment of truths. When he published his idea that gravity is the way space and time curve, a soldier at the front, under grey skies and long fields, read those pages and felt a particular stillness. In the intervals between duties, he wrote back with a gift, the exact shape a single round unspinning mass should carve in space-time. He did not live much longer, but the shape remained like a calm landmark on a coast. It told of a border where light turns inward, where routes that once led everywhere narrow into a single path. His calculation was like a stone placed carefully on a shelf, and all our later thoughts have glanced off its smooth surface and learned something from the sound. A few years later, when the moon stepped in front of the sun and the day dimmed to lavender, another patient soul measured how starlight bent around the sun's edge. He traveled to islands where the air tasted of salt and the night carried a different scent, and he stood beneath unfamiliar birds to set up glass and brass. The eclipse confirmed what the first man's equations suggested, and the world smiled. Not because it had gained a trick, but because two ways of knowing, the soft trust of observation and the quiet strength of reason, had clasped hands. The bend in starlight would be larger near a darker, denser heart, and if a hole in the world formed by great collapse, the bend would become a permanent bowing, an invitation inward from which light could not return. On a ship crossing the ocean, a young thinker with eyes like a winter lake considered how much pressure light and particles could provide to hold a star up. He calculated, stepping carefully, counting the patient steps of nature's rules, and he found that for the heaviest stars, even the most stubborn pressures would yield. The path ending in the quiet depth of a black hole was not an exotic accident. It was an ordinary conclusion written in gentle ink. If mass is high enough, gravity will complete its sentence. He was challenged gently and then not so gently by a man he respected. The older man's voice was musical and insistent. Years later, the older voice would soften, and the younger would be honored. In the meantime, the arithmetic of collapse sat on the table like a bowl of water, perfectly still, reflecting the ceiling lamp, waiting for anyone to look. From those early rooms come the thoughts that guide our drifting tonight. Nothing crashes, nothing shouts. The curves of equations, like the edges of leaves, find their way into the larger canopy. When a star finishes its long work and the inner layers fold in, there is a moment in the story where the ordinary order of inside and outside becomes less strict. The horizon forms, not as a shell of substance but as a rule about paths. Theophoton there points outward, and in the next moment, as the ground itself tilts, finds that outward has been rewritten to mean in. Imagine a gentle walkway that has been placed on a hillside. At some inclination, Rolling a marble up still brings it back to your hand. At the horizon, what was up becomes down, and down becomes the only way. Long after the first calculations, in rooms lit by desk lamps and the light reflected off chalkboards, others asked about the horizon's moods. They found that in the absence of turbulence, the area of that border never shrinks. It is as if the horizon keeps a quiet ledger and refuses to erase entries. When matter and light fall in, the boundary is amended, wider, steadier. When two such hollows meet and merge, they form a new, larger one. And the new border's area is larger than the sum you might have anticipated, the way two soap bubbles join and the surface finds a new, smoother balance. That was the law as written by those who listened to gravity's preferences and gave them a simple form. It was a law not of speed or pressure, but of patience. The horizon's vocabulary includes growth, not retreat. There were whispers then of something stranger, an almost imperceptible warmth. At first it was only a rumor passed from mathematics to intuition, a shy claim that when the horizon holds its ledger of information, it cannot do so in perfect silence. A temperature, tiny for large black holes and more noticeable for small ones, must belong to the border. A faint glow, a trickle of particles escaping, as though the horizon cannot help but hum when the quantum embroidery of space is considered. It surprised everyone. A thing whose name was darkness would radiate, not brightly, not with fire, but with the patient, delicate insistence of the very small. Even this could be allowed without drama. It was another way the universe balances its accounts. And for the horizon scattered throughout the deep, for almost all practical purposes, that glow is so gentle, so slow, that a million lifetimes would pass, and the border would scarcely thin. You can let that thought rest like a feather. When people talk in a hurried way about something expanding faster than light, their words often stir dust in the air that need not be disturbed. The horizon's widening, when mass or the background swell of the universe contributes, is a change in shape, not a sprint. It is a redefinition at the edges, a redraw of a map's coastline as the tide adjusts, in more than one way of measuring. That redraw can be quick enough that if you applied everyday thinking you would scold it. But everyday thinking is a beautiful tool with a certain scale. You would not measure the night with a ruler. You would not weigh a feeling on a kitchen scale. And you would not ask a horizon to step carefully within the footsteps of familiar objects. The river that carries the leaf faster than any swimmer can move is not disobedient. It is large. It is the background, not the actor. The river is a kind image to carry. Picture space as a very deep, very slow flow. Far from any heavy masses, it meanders. You can choose to swim or drift, and either choice feels safe. As you drift towards a black hole, the river's pace increases. At some place, its speed equals the fastest any fish could ever swim. At that place, even the quickest effort upstream does no more than hold your position for a heartbeat. You are at the horizon. Inside, the flow is more determined, directed inward with a grace that is not negotiable. Nothing swims out, not because anyone took away its muscles, but because the stream has become the only story. When the river's banks widen because rain falls, when matter arrives, when the background universe itself swells, the place where the current matches the fastest swimmer moves outward. No water has broken a rule. The banks have simply found a new line. Those banks, once formless in our imagination, have been glimpsed. We built a planet-sized eye by teaching radio dishes across the earth to trust each other's timing, to share their nights, to be one system. In that shared listening, we saw the shadow of a black hole in a galaxy far away, a soft, round darkness framed by a ring of light where space has instructed photons to circle the drain before deciding their fate. Later, we saw the quieter one at the center of our own galaxy, its heart beating so slowly that the image had to be coaxed out of flickering frames. What we saw was no more than a silhouette, but a silhouette tells you a great deal about a person. The ring's size told us that the geometry at that place agreed with the old equation's lines. The uneven brightness told us the light swirling there was beamed more one way than another by motion and field. The darkness in the center told us that the border's message, no light from within, still stands. At human scales, we had caught a lullaby sung by the cosmos to itself. Sometimes, when the subject is black holes, you may feel a tug at your sleeve that whispers, "To what end?" Beyond their calming mathematics, beyond their photographs, is there a story of meaning? You might consider the way they shape galaxies, anchoring their centers, influencing the rate at which stars are born. You might consider that they are part of the grand exchange between order and simplicity. Matter arranges itself into delicate forms, clouds, coral reefs, cities, thoughts, and over long mornings of the universe, gravity gathers those arrangements into simpler, quieter states, storing time in a different way. In doing so, horizons grow. They grow in response to the life that has passed by, the light that has moved, the heat that has been traded. They are a record and a muted voice of what has once been complicated. There are echoes, too, in the ripples of space-time itself. A few years ago, in forests of mirrors cooled and protected, we learned to hear the chirp made when two black holes touched and became one. The sound was not a sound in air. It was a stretching and squeezing of distance, smaller than a proton across kilometers, a wave of nearer and farther passing through us and everything else with no preference. The chirp began low and rose like a kettle coming to a gentle boil, then ended in a soft thrum as the new horizon wrinkled briefly and smoothed. In that small, precise music, we heard heavy objects moving through a distance no instrument could bridge, and yet the wave carried their story to us as surely as a scent carries the memory of rain. Those chirps happen when horizons grow quickly. The area leaps by the rules written earlier, and the growth can be read in the pattern of the wave. If a horizon's edge seems to race, it does so in those numbers, in the way the wave's song changes measure. There are speculations that lie like seashells on the shore. You can pick them up and listen without needing to swear that what you hear is the ocean. Some say that the swift growth of certain horizons hints at layers beneath our usual idea of space. Perhaps thin extra directions curled too small to walk. Perhaps something like a fabric with threads we have not yet seen. Others say that what we name growth is better understood as unveiling, a parting of curtains to reveal a room that was always there. We allow these thoughts to sit in the air without hurrying them. The universe has tolerated our curiosity for a long time. It will keep tolerating it while we sleep. Inside the horizon, the vocabulary of now and later shifts. If outside you can point and say, the future is that way. Inside the arrows on the signs all point inward. You cannot refuse this. It is not punishment. It is geometry. To stand at that border is to be at a threshold where time and space exchange masks, where what was a place becomes an inevitability, where toward the center is not a direction you choose but the definition of tomorrow. Some have wondered whether in mathematics there are other shapes, white holes, that do the opposite, allowing nothing to enter and only to leave, or wormholes that connect distant places through quiet tunnels. These are lovely thoughts. In the more serious, gentle parts of the subject, they are fragile, supported by assumptions that may not hold in the weather of a real universe. Still, it is not a crime to smile at them before setting them softly back on the shelf. The core itself, the singularity, is described by equations with a modest apology. Our best classical map says that curvature grows without bound, that density forgets the meaning of limit, that time ends in a point. We suspect the map is asking for help there, and that another layer of description, a quantum theory of space and time, will gently cap the mountain, take the edge off the cliff. But that description is not yet ours. We are like listeners in a hallway outside a closed room, hearing the murmur of voices and the occasional ring of laughter, knowing there is a conversation and waiting for the door to open. In the meantime, we have the outer rooms beautifully furnished and sufficient for a long, deep evening. The silence attributed to the center is not a threat. It is a placeholder, a blank page where the next chapter will be written. How pleasant that there are still blank pages. There is a particular tenderness in the idea that information, the particular arrangement of particles and light that once shaped a star, a cloud, a library, a voice, is not lost when it crosses the horizon, but is written in a new language on the border itself. Its details may be scrambled beyond our ability to read, but the total count remains. This is an idea about bookkeeping and about kindness. A universe that keeps careful records is one that forgives us for not always being able to read them. At night by a window, you may have the sense that your thoughts are exhaled and hang like breath on glass, leaving a trace. The horizon is a glass no one can see through, fogged with a record of what has brushed it. It glows very faintly, with the insistence that the story is not erased, only rewritten. If at times these matters feel like riddles that dissolve when you hold them too tightly, you are in the company of the best minds who have worked on them. Many times a brilliant equation has been written, admired, and then, through a gentle test, found to erase itself like chalk wiped off a board by a sleeve. Divergences appear. Quantities go to places where we do not know how to follow. We try new paths, subtracting infinities that cancel, building bridges between the small and the large with careful regularity, asking the universe for mercy by checking our guesses against what is seen. Some of the bridges are sturdy. Some sway and ask for a steady step. The phantom equation, the one that would explain how the small and the large share space with black holes at their center, waits. Say it is not cruel, it is patient. It will arrive when our minds have slept enough and woken enough to greet it. You might enjoy the thought that the universe watches itself through us. A black hole expands, its ledger of area adjusted by a falling star, and half a galaxy away, a sentient creature turns a dish toward the quiet. The creature's brain, built from old starlight, decodes signals emitted by gas warmed by its dance near the horizon. In doing so, the universe has made an eye to see its own mask. There is a reflective equality tucked into the folds of reality, an echo of observation. When we measure a pulse, we change what we are. When the pulse is measured, it becomes part of the world's story. The feedback is soft, not the loud paradoxes that make headlines, but a tender reciprocity. Through instruments and inquiry, the cosmos folds back on itself like a blanket being turned, exposing one side then the other, still the same blanket, still warm. If you've ever walked along a shoreline at twilight, you know the thin comfort of liminal places. The water's edge is neither land nor sea. Your steps hold two maps at once. In black hole physics, there are edges everywhere, and we learn to walk them. The horizon is one. The boundary between what we know and what we merely name is another. On our side of those lines, we can ask questions like children with endless afternoons. How does the area grow? How quickly does the ring flicker? When two horizons meet, what shape do they choose? On the other side, we are quiet. We are not ashamed to be quiet. We are proud to let a mystery be a sleeping cat. The next time someone says that a black hole grows faster than light, you may smile with a kindness that comes from having taken a slow breath. You can imagine the current deepening, the banks moving. You can imagine starlight watching as the border extends to include what has come to rest there. No courier has been outrun. No rule has been broken. Our language has been asked to describe a boundary rather than a thing, and in doing so it picks up the habit of exaggeration. You can translate the exaggeration into the calm of geometry. This is a practice you can extend to many parts of life. Listening for the current beneath the scattered leaves, the policy beneath the headline, the pattern beneath the noise. In another time, perhaps in another universe, perhaps in a part of this one we cannot reach, there may be a way for what we call a singularity to be not an ending, but a turn. Stories of bouncing beginnings, of fresh expansions seeded by the cores of previous collapses, have been told at blackboards in long afternoons and taken for walks in the minds of those who prefer oak trees to offices. We do not need to decide tonight. It is enough to know that the mathematics allows such possibilities to sit politely in the waiting room. The receptionist does not tell them to leave. We pass them and nod, and they nod back. And everyone understands that the consultation will take place when it is meant to. As the room around you grows quieter and you settle more deeply into the large chair of your own body, notice how your thoughts slow. They do not stop. They do not need to. They grow like tides in the mind, moving in and out, bringing shells and drifting wood to the shore and then pulling them back, leaving the sand smooth. In that rhythm, the universe's larger breathing is mirrored. The event horizon breathes, the galaxy breathes, the background light breathes as it cools over eons, and here you are, keeping time with all of it without effort. This is not romance. It is a plain, honest fact with gentle edges. You are part of a pattern that does not require you to be any particular thing other than present. If you prefer an image to hold while sleep approaches, imagine a lantern carried along a path at night. The light falls on the grass at the lantern's feet, and beyond that circle is only darkness. As the lantern moves, the circle of light slides forward. The edge of the circle, the frontier between seen and unseen, moves faster than any ant within the circle could walk. But no ant is being asked to run. The edge is not a thing. It is a condition. The horizon of a black hole is like that lantern edge, except the geometry carries the lantern, and the light is the measure of what can return. As mass joins the whole, the circle's edge enlarges. It is not disobedient. It is simply the definition of the circle in a new place. You could fall asleep now with these simple, old friends. Light that moves steadily, space that can flow, time that stretches where gravity is strong, boundaries that grow in answer to what they receive, and the patience of unanswered questions stacked like books by the bed, waiting for the morning when you will open them without hurry. The universe is not offended by sleep.